Hi.
Welcome to Manifested Publishers.
Welcome learners, my name is Stephen Kariungi. I am presenting to you a topic in Form 1 Biology, and the topic is cell physiology as indicated here. First of all, I would want us to go through the objectives of this topic. So we look at chapter objectives. The first one, we need to understand what is cell physiology. So we need to understand the meaning of cell physiology. Number two, we should also be in a position to relate the cell physiology and the structure of the cell membrane. So the other objective is to be able to relate the process with the semi-permeability of cell membrane. Number three, we'll also be able to state the meaning of three physiological processes. These are diffusion, osmosis, and active transport. So, be able to state the meaning So you'll be able to state the meaning of those three terms, the term diffusion, osmosis, and active transport. Objective number 4, we'll be able to study the factors that affect these three processes, the factors that affect diffusion, osmosis, and active transport. So that is objective number 4. Then we go to objective number 5. We should also be in a position by the end of the topic to describe some of the experiments that one can carry out to investigate diffusion, osmosis, and active transport. So we should be able to describe experiments to investigate the above processes. And finally, the objective number 6, we should be able to distinguish between Turgor and plasmolysis. Those are two terms that we'll also be learning in the course of the topic, and we should be able to distinguish them. So those are the objectives that we shall be fulfilling in the study of the topic cell physiology. So from there, we'll embark on an introduction. And we want to understand what is the meaning of the word cell physiology. As the word suggests, it has something to do with the cell. And the fact that it ends with a logy, it means that it is a study. So in this case, in cell physiology, we study the cell functions. So in this case, we shall look at the various structures that are found within the cell and how they carry out their functions. So we will say that cell physiology is the study of cell functions. And of course, in a cell, we know that we have different structures. We have the cell membrane, we have the mitochondria, we have the chloroplasts, if it is a plant cell. So we need to understand how those structures function within the cell. So basically, we shall be dealing with cell physiology. Now, a very important aspect of cell physiology that we also need to look at is the structure of cell membrane. We need to look at the structure of the cell membrane, because before something gets into the cell or out of the cell, it has to go through the cell membrane. So the cell membrane is a membrane or a layer that is made up of two things. It's made up of something that is called a phospholipid and a protein layer. So it's made of two layers, i.e. phospholipid. I'll explain what is a phospholipid and a protein. So it's made up of those two layers. A phospholipid is a fat layer. Anything that ends with the word lipid, it means that it's either a fat or an oil layer. Then, of course, the other one is a protein layer. So what we are basically going to do, we are going to have a diagram showing the cell membrane and how it looks like. So the cell membrane looks like that. First of all, there is the first layer, assuming that this is the outside and this is the inside. So this first layer is the phospholipid. Is the phospholipid layer, and then the one that is marked using a different color, that is red, that is the protein layer. So basically we are saying that a cell membrane is made of a phospholipid layer or a fat layer and a protein layer. Now, in between the protein layer, there is a small opening here, and that opening we call it the pore, P-O-R-E. It's a hole that allows substances to get inside the cell and also outside the cell. So that opening is meant for that. We shall look at the characteristics of the cell membrane. So this is basically the cell membrane structure, which we have said is made up of two layers. There is a phospholipid layer on either side, then there is the protein layer in between. There is a protein layer in between. So it doesn't have to be in one position. It can be in a number of positions. But basically, there is the phospholipid layer and there is the protein layer. Then in between the protein layer, there is a pore, or there is a hole that allows materials to get in or out of the cell through the cell membrane. And then the other thing that I want us to look at are the properties of the cell membrane. We look at the properties of cell membrane. One, we say that the cell membrane is semi-permeable. The cell membrane has what is called semi-permeability. And that means that it allows only the small molecules to pass through, but not large ones. So it's only allowing the small molecules to pass through the pore. Yeah? Those, if molecules are small enough to fit the pore, they can pass through, in and out. But if the molecules are large, they cannot pass. So we say that the cell membrane is semi-permeable, or we can say it's selectively permeable. So you can also stroke that with selectively permeable. It means the same thing. Now, characteristic number 2 is that the cell membrane is sensitive to temperature and pH. It's sensitive to temperature and pH. And the reason for that is because the protein layer and the lipid layer, they are sensitive. Yeah? If the temperature is too high, then the cell membrane is affected. If the temperature is also too low, it's also affected. Same case applies to the pH. So pH is the degree of acidity or alkalinity. So it's sensitive to temperature and pH. And lastly, number 3, the cell membrane is polarized. Polarized means that it has charges. It has charges that are positive and negative. Has charges that are positive and negative. So basically, we have looked at the objectives of the entire topic. We have listed them down. Then we have gone ahead and defined what is cell physiology as the study of cell functions. We have looked at the structure of the cell membrane, and we have seen that the cell membrane is made of 2 layers. There is the phospholipid layer and there is the protein layer. And then we have also said that in the protein layer, there is a pore that allows materials to get in and out. Then we have looked at the properties, 3 properties of the cell membrane. One is its semi-permeability or selectively permeable, meaning that it is selective. It selects the small molecules to go through, but not the large ones. It's also sensitive to changes in temperature and also pH. And finally, the cell membrane is polarized. That means that it has both positive and negative charges. So our lesson for today will end there. Then we'll have an assignment based on what we have learned. So the first question, we define the term cell physiology as we have learnt it. 2, we describe the structure of cell membrane, description of that structure. And then number 3, we state 3 properties of cell membrane. So we are going to stop there for today, and we shall continue from there next time. Goodbye.
Greetings, class. Welcome to today's lesson. We're going to look at grammar, but majorly Form 4 grammar, and we're looking at phrases as a broad spectrum, yes, but we will narrow it down to participle phrases. But before we get to participle phrases, we're going to look at what phrases are. So I'll just introduce. So a phrase from Form 1 to Form 3, you have been introduced to what phrases are. And right from Form 1, you've been told that a phrase is a group of words that functions as a single unit in a sentence. So it's a group of words, but it functions as a single unit in a sentence. This single unit could be, it could function as a noun or a verb or an adverb, an adjective, or a participle. Oh, not to forget a preposition. Preposition. So this group of words, this phrase that we're talking about, will function as a noun. It will be a group of words, but it will function as a noun. It will be a group of words, but it will function as a verb. It will be a group of words, but it will function as an adverb, or an adjective, or a participle, or a preposition. So in Form 1, you are introduced to noun phrases. Noun phrases. Before we get to noun phrases, this phrase, it consists of the head word, and or modifiers. So it could either be just the head word itself, like in noun phrases. Mary is just a noun phrase. But now, when it comes to preposition, the preposition cannot function on its own, and you call it a prepositional phrase. But in noun phrases, you can call Mary a noun phrase. But now, when it gets to preposition adjectives, you'll need to have other words that make up the phrase. So the phrase consists of the head word and its modifiers. So if it is a noun phrase, it will consist of the noun and the modifiers. These modifiers, when I say N, now N means what? Noun. So the modifiers could be determiners. It could be quantifiers. It could be, so let me give you examples of determiners. We have a, an, the. Quantifiers could be some, few, could be even pronouns, e.g. my, this. Okay, those ones are modifiers of what? The noun. What do we mean by a modifier? A word, it is a word that describes a noun. A modifier, a word that, maybe we can say, gives more information about a noun. So that when we say that the noun phrase will contain the noun and its modifiers, then it will be the noun, for example, boy. So you add modifiers to it so that it makes up the noun phrase. So when you say this boy, you're telling us more about which boy you're talking about. You're giving us more information about which boy. If you say a boy, no problem. It could be any other boy, okay? Or maybe this, if it is not just a boy, it could be even adjectives. Sorry, before we continue, even adjectives are part of modifiers of noun, because adjectives describe nouns. So when they are combined together with the noun, they make up the noun phrase. They will function as the noun in the sentence. The noun phrase will function as it's a group of words that functions as a noun. As a noun in a sentence. So you say this boy. So this boy is a noun phrase. A boy is a noun phrase. Give me a word like pen. Pen. You can add my blue. Already you have this my blue are modifiers. They make up the noun phrase. They must work with the noun because they give us more information about the noun. So all of them, they are called what? This is a noun phrase. So my blue pen is lost. So in the sentence, my blue pen is functioning as a noun in the sentence. Now, when we get to, we'll look at a lesson where we'll be looking at the functions of noun in sentences. And nouns can function as the subject, the object. And when we'll be looking at that, you'll now understand how it functions as the what? The noun in the sentence. The noun functions as a performer of an action or the receiver of an action in a sentence. So today, we're just looking at phrases and reminding ourselves, because I'm assuming that you've already learned about it. So we are reminding ourselves what we know about phrases right from Form 1. So Form 1, we looked at noun phrases, and I've given you an example of a noun phrase. This boy, a boy, even Mary, 3 girls, you know. Remember, this word 3 is a modifier. It must, when it functions like this, it becomes a group of words that is functioning as a noun. So we come to verb phrase. We come to verb phrase. Let me just write. So a verb phrase is a group of words that function as a verb in a sentence. So the verb phrase will contain again the head word and its modifier. So the head word in the verb phrase is a verb. The head word in the noun phrase is the noun and its modifiers. So the verb plus its modifiers will now make up the verb phrase. Now, one easy thing about verb phrase, whatever modifies a verb, usually an auxiliary. Auxiliaries. So that we can say, so the verb cannot function in its own without the auxiliaries. So that we have is eating. This already is a verb phrase. So what are the auxiliaries? Before I give you, already this is a verb phrase. It's a verb phrase. Auxiliaries include primary. Auxiliaries include primary and modal. So under primary, we have forms of the verb to be, e.g. is, was, forms of do, forms of have. And then modal auxiliaries include may, shall, will. So all this, when they occur with a main verb is an action word. A verb is an action word. So for you to make up the verb phrase, you will need the verb and its modifier. Whatever functions with the verb is one that gives us more information. It gives us the state of the verb. In this case, the state will be like, a verb can just be, for example, we can have a verb like be, but it has its forms, e.g. is, was, were, are. So for you to say we are here, we can say we are here, but if it is used in a sentence, in this case, it will be used as an auxiliary. Now, another main verb could be, here it can be used as an auxiliary, but another main verb could be work. So you can't say John work there. You must say John is working there. So that gives us the state. Which state is it? Is he working now, or was working, or is working, or is still working? You know those words. So that's why we need an auxiliary, a helping word. Auxiliaries are also called helping verbs. They help the verb. They help us know how the verb is functioning in that sentence, in the aspect of tense, in the sense of tense, because verbs gives us actions. But which actions? When were they happening? Okay. So here the verb will have an auxiliary, and a verb, so that it can make the what? The verb phrase. So an example of a verb phrase is very easy. We can have is working, have been working, maybe was working. All these make up the verb phrase. When I write VP, just know it's a verb phrase. So it will contain the verb and the what? the modifiers. The modifiers of a verb phrase are the auxiliaries only. Not like in a noun where we have pronouns, quantifiers, what, that describe the noun. Here we only have the modifiers. The only word that works with a verb is an auxiliary in this case. All right? So that is all for a verb phrase. Then the next one, the next type of phrase is a prepositional phrase. So again, this is a group of words that functions as a preposition. I won't repeat writing because by now I think you know the drill. It's almost the same kind of description, only that here it will function as a preposition. It will contain the head word, which is the preposition, and its modifiers. So the head word of a preposition, the modifiers of a preposition are the noun phrases. The noun. So that we can have, for example, a preposition like at, or in, or under. So under the table, in a car, at the cinema. Why do we call them modifiers? They tell us where the preposition, how the preposition is functioning, as in where. How do prepositions function in sentences? They tell us where something is. So for it to function as a prepositional phrase, it cannot occur on its own. It must occur with a noun phrase. So the head word here again, the head word here is a preposition, and the modifiers are the noun phrase. So this is an example of a prepositional phrase. Number 4, we have the adverbial phrase. The adverbial phrase. Again, like we said before, it will be a group of words that function as a what? As an adverb. What is an adverb? Is a word that gives us more information about a verb. For example, they walked. If it here is a verb, walked. Then when you add quickly, that is a what? Quickly is an adverb. So here we're looking not at the verb, we are now looking at how we can, which words can function with what? Quickly. All right? So, like we said from the beginning, that the noun phrase will have the head word and its modifiers. So here the head word is the adverb, okay, and its modifiers. Okay, adverbs occur on their own. For example, you can only have the adverb. The modifiers of an adverb are intensifiers. Intensifiers are also called adverbs of degree. Adverbs of degree. So that when you say quickly, then you say the intensifier here. Adverbs of degree, let me just give you examples. They include very, to. Okay, those ones are some of the examples of the adverbs of degree. So that when they work with when they do what? When you put them together with another adverb, then it will be functioning as an intensifier. But when joined together, it will be an adverb phrase. So the example will be very quickly. So this is an adverbial phrase. Even examples like last year. Examples like too often. Okay, all these two verbs, two adverbs. Okay, they function as what? The adverbial phrase. We say that what do you call an adverbial phrase? It's a group of words that function as an adverb in a sentence. So that you say, he walked very quickly. So if you're asked to identify the adverbial phrase in the sentence, you just underline both of these. Okay? All right. Now we have the fifth one, which is an adjectival phrase. Adjectival phrase. Again, like we said, an adjectival phrase is a group of words that functions as an adjective. So it will be a group of words that will function as an adjective. So in this case, the head word is the adjective and its modifiers. The modifiers in this case are, like here we say they're intensifiers. Here we say they're auxiliaries. In the noun phrase we say they're determiners, quantifiers, adjectives themselves. And here we are also including again intensifiers. Remember, an intensifier is not a new word. It's just an adverb of degree. But now it tells us to what extent, to what degree. All right, that's why we call them intensifiers. They tell us the intensity of an action. So here we have maybe an adjective like beautiful. So we add an intensifier to, then it becomes what? An adjectival phrase. Too beautiful. If it is tired, too tired. Okay, that's another adjective. Tired, too tired. Enough, fresh. If it is fresh, you can say fresh enough. We're saying that. So those are the basic ones that you've learned, because noun phrases are taught in Form 1. Verb phrases and adverbial phrases are taught in Form 2. Prepositional phrases and adjectival phrases are taught in Form 3. So all that is just like looking at how, basically we're just breaking down words, but now in terms of phrases. These are things you've learned. You've learned about nouns, verbs, adjectives. Now we're looking at them in a broad perspective, but now we're looking at them in a broad perspective in terms of phrases. And today we're also going to introduce a new one, which is called a participle phrase. A participle phrase. We've said that the phrases can function as nouns, they can function as verbs, they can function as adjectives, they can function as prepositions, they can function as adjectives. And again, they can also function as a participle.
Welcome to Manifested Publishers.
Welcome learners, my name is Stephen Kariungi. Today we discuss another physiological process, and this is active transport. So far we have discussed diffusion and osmosis as physiological processes by which materials move in and out of the cells. Today we are going to discuss active transport, and this is the movement of particles from a region of low concentration to a region of high concentration against a concentration gradient. So in this case, we are saying that particles can move from a low concentration to a high concentration. And that's what we are calling against a concentration gradient. And this process requires energy, and hence the term active transport is a process that consumes energy. So you can say that this is movement of particles against a concentration gradient, with the utilization of energy. So it is believed that for the particles to move against a concentration gradient with utilization energy, there are some carriers that are required to carry these particles across the cell membrane of plant cells or animal cells. So in this case, we find that a lot of energy is spent to make sure that these particles move against a concentration gradient. So you can say that it is believed that carriers combine with the particles and move them across the cell membrane. So we're going to next look at what are some of the factors affecting active transport, factors that affect active transport. And the first thing is to know that active transport is a process that consumes energy or utilizes energy. And therefore, any process that interferes with respiration, that is the energy production within the cells, will also affect active transport. So you can say that any factor that interferes with respiration, that is energy production in the cells, will also interfere or will also affect active transport. So these factors include we have A, the oxygen concentration, substrate concentration, the presence of inhibitors, pH, so all those factors, they will affect the rate of active transport, and therefore they affect the rate of respiration or energy production within the cells, and therefore they will also affect the rate of active transport. Of course, oxygen concentration determines how much energy is produced. The substrate being broken down, the presence of inhibitors which tend to interfere with the functioning of the enzymes, and also the pH, not forgetting also the temperature. Lastly, we look at the role of active transport, in living organisms. In other words, we are asking ourselves, how is active transport important in living organisms? Number one, we have absorption of mineral salts from the soil by plants. So plants will absorb mineral salts from the soil by active transport. Absorption of digested food materials from the small intestines or from the ileum of mammals. removal of excretory products in living organisms, reabsorption of useful substances in the kidney tubules. So all those are processes that involve active transport. They are processes by which the particles or the molecules move against a concentration gradient. Absorption of mineral salts from the soil by plants, absorption of digested food materials from the ileum, removal of excretory products in living organisms, and reabsorption of useful substances in the kidney tubules. So the first question in the assignment, define the term active transport. 2, state and explain 4 factors that affect active transport. And 3, state 3 roles of active transport in living organisms. So our lesson will end there, and that marks the end of the topic of cell physiology. We shall meet another time in a different topic. Goodbye.
Welcome to Manifested Publishers.
Hello learners, my name is Stephen Kariungi, and we continue with our topic of discussion. The topic is acids, bases, and indicators. We are on the third property where we are discussing neutralization, which means the reaction of dilute acids with bases. And remember, we say that bases can either be metal oxides or metal hydroxides. We also learned that those bases that are soluble in water, we refer to them as alkalis. And we also have other bases that are insoluble in water. So we're going to have equations showing acid-base neutralizations. Equations showing acid-base neutralization. And the first one, we had used the dilute hydrochloric acid and sodium hydroxide. So we expect to get a salt and water only. So the salt will be sodium chloride. Sodium chloride. Remember, we said that from hydrochloric acid we get chlorides. And then, of course, the other product is water. So we have the acid, and this is the base. And of course, this is what we are calling neutralization. So from this, we can be able to define what is an acid and what is a base. For example, we can say that an acid is a chemical substance that reacts with a base to form a salt and water as the only products. And we can say that a base is a chemical substance that reacts with an acid to form salt and water. So we can say that an acid is a chemical substance that reacts with a base to form salt and water only. So an acid is a chemical substance that reacts with a base to form a salt and water only. So we can also define a base. On the other hand, a base is a chemical substance that reacts with an acid. Reacts with an acid to form salt and water. Only. So we have seen that we can use that equation to define what is an acid and also to define what is a base, because we are saying that an acid reacts with a base to form salt and water. A base reacts with an acid to form salt and water. So more examples. We can have an acid such as sulfuric acid and a base such as magnesium oxide. Remember, a base can also be a metal oxide, not just a hydroxide. It can either be an oxide or a hydroxide. So here we'll get a salt, magnesium sulfate, plus water. We can use nitric acid plus calcium hydroxide is still a base. So we'll have calcium nitrate plus water. Another example, we can use phosphoric acid plus sodium or potassium. Let's use potassium hydroxide. So we'll have potassium phosphate. So we'll get a phosphate because we are using phosphoric acid. Plus water. So in all the acid-base neutralization, there must be a salt and water. Salt and water. Different salts depending on which acid we have used. When you use hydrochloric acid, we get a chloride. When you use sulfuric acid, we get a sulfate. When you use nitric acid, we get a nitrate. When you use phosphoric acid, we get a phosphate. So that is basically that as far as the neutralization is concerned. You can still take one more example and say, for instance, lithium oxide plus hydrochloric acid is going to give us lithium chloride plus water. So in all these examples, we are forming a salt and water. In a neutralization reaction, an acid-base reaction, salt and water are the only products. And that's why we defined an acid as a chemical substance that reacts with a base to form salt and water. We also defined a base as a chemical substance that reacts with an acid to form salt and water only, or as the only products. Can have our assignment. So we have two questions in the assignment. The first question, what is neutralization? The second question, complete the following equations. A, potassium oxide plus sulfuric acid, you complete that. Sodium hydroxide plus nitric acid, you complete that. And then calcium oxide plus phosphoric acid, you complete that. So we're going to stop there for today. Until the next time, goodbye.
Hi learners, welcome to our lesson today in solving problems in pressure. In the last lesson, we solved problems in pressures in solid, but today we are going to solve some questions involving calculating maximum and minimum pressure. Welcome, I have here two questions. The first question is a block measuring 20 centimeters by 10 centimeters by 5 centimeters rests on a flat surface. The block has a weight of 3 Newton. Determine the maximum pressure it exerts on the surface. So we have our solution. First of all, I said that when you get a question like this one, you must list what you have been given. In the question, you have been given the dimension of block, dimension of block given by 20 centimeters by 10 centimeters by 5 centimeters. Then you have weight equal 3 Newton. Remember, weight and force, it simply means the same thing. So if you have been given weight, this one is just the same as force. We are being asked to determine the maximum pressure. And maximum pressure denoted by P max is given by force over minimum area, denoted as F over A minimum. So we have force, but we don't have minimum area. So when we want to calculate that minimum area. So working here, for minimum area, we use these dimensions that have been given to calculate 3 areas. And for that one, we can tell which one is minimum and which one is maximum. For this case, we have 20 times 10 is equals to 200 centimeters squared. I can take 20 times 5. This one will give me 100 centimeters squared. Then I can have 10 by 5. This gives me 50 centimeters squared. From these 3 areas, we can tell which one is maximum and which one is minimum. 200 is the highest one, meaning that it is maximum area. Then 50 is the lowest one. You know, this one is the minimum one. So this one, it is A max, and this one is A minimum. Remember, 100 is in between, but we are here just to determine the maximum and minimum. Now, remember, this area, it is in centimeters cubed. We must change it to the SI unit, that is into meters squared. In the last lesson, we said that that is 10,000 centimeters squared is equal to 1 meter squared. So what about 50 centimeters squared? So cross multiply, we have 50 centimeters squared times 1 meter squared, then divide by 10,000 centimeters squared. This gives me 0.05. Is it 5? We can use our calculator. That is 50 divided by 10,000. Yeah, it is 0.05 meters squared. So I have area, which is a minimum. This is a minimum. Then I have force. Meaning, if I want to get P max, our P max is just equal to force, which is 3, divided by a minimum. A minimum, which is 0.005. So if I take 3 divided by our answer, it is giving me 600 pressure Newton per meter squared. This represents the maximum pressure that it can be exerted by that block on the surface. This is the first question. Now, for the second question, we can work out the second question. The second question, a brick 20 centimeters long, 10 centimeters wide, and 5 centimeters thick has a mass of 0.5 kilogram. Determine the part A, the maximum pressure that can be exerted by the brick on the flat surface. Part B, the minimum pressure that can be exerted by the bricks on what? Brick on a flat surface. Now, first of all, we list what we have been given. We have been given the dimension. It is question 2. Dimensions: 20 centimeters by 10 centimeters by 5 centimeters. Then we have mass, 0.5 kilograms. Now, part A. Part A, we are being asked with the maximum pressure. And maximum pressure, we have said, maximum pressure is given by force over minimum area. Minimum area. From the formula, we have not been given force. We don't have a minimum. But mass is going to assist us to find this force. So, our force, from the last lesson, we said that force is given by mass times force of gravity. That is m times d. That is 0.5 times 10. It is giving me 5 newtons. Then for maximum and minimum area, we use the dimension of the block. Now, area 1, we may have 10, that is 220 times 10. 20 times 10, 200 centimeters squared. We may have 20 times 5, which is equals to 100 centimeters squared. And we have another one, 10 times 5, giving me 50 centimeters squared. So after finding this area, we can determine which one is maximum and which one is minimum. 200 is maximum. This is a max. Then this one is a minimum. Now, we must express this area into the SI unit. That is, this 50, we express it into meters squared. So we have 50 centimeters squared into meters squared. We have 10,000 centimeters squared is equals to 1 meter squared. What about 50 centimeters squared? We cross multiply 50 by 1 over 10,000. 0.005 meters squared. So that is our air minimum. Now we substitute in our equation. We have force is 5, then air minimum is this 0.05. So this one represents air minimum. So when I substitute in my equation, I have 5, then divide by 0.005. 0.005. We can use our calculator, that is 5 divided by 0.005. It is giving me 1,000 pressure Newton per meter squared. That is our maximum pressure. Now, for minimum pressure, B, for minimum pressure it is always given by force over maximum area. This is P minimum. So this is just the same as force over air maximum. This is noted by that. But remember, our force, we have calculated it. It is here. Then our air maximum, air max, it is here. It is just a matter of converting this one into the SI unit. So converting, that is 200 centimeters squared into meters squared. We have 10,000 centimeters squared is equals to 1 meter squared. So what about 200 centimeters squared? So we have 200 times 1 over 10,000. This is 0.02 meters squared. So this is air max, our air max. So we substitute in our equation. So our force is still 5, then divided by maximum area or air max, which is 0.02. So for this one, it will give me 5 divided by 0.02. It is giving me 250